Hi, everyone. My name is Ankur Kotwal. I'm a developer advocate on the Google Cloud team. So something about me, I was actually born in India, but I have lived the last 30 years in Sydney, Australia. I get to come to India mostly for work, actually, every few years. And one of the things that constantly brings me back to India is you all, the community. There's always such enthusiasm, excitement about whatever it is that Google has to share. And I really, it really touches my heart that there is such passion towards everything that we do there. So, I'm going to talk to you about Anthos. Now, Anthos means different things to different people. It's a pretty broad product suite, and so we're going to go in pretty deep to start the morning. Before we go too far into Anthos, I want to take a step back, actually. I want to take you on a journey of how we got here. There have been a handful of fundamental shifts in technology over the last 7 or so years. These shifts have made it different in the way that we build our applications and the way that we operate them in the cloud as well. So the first one is Docker. So actually, Google has been running our software in containers for over 15 years. And it gave us a real competitive advantage because we were able to use containers and put more containers on our infrastructure than perhaps some others were able to. So we open sourced our implementation of containers to the Linux kernel in about 2006, 2007. If you've ever worked with that implementation, it's called C groups, which stands for control groups. So we open sourced that based on our experience. Docker came along in about 2012 and put some really awesome tooling around containers. So it made it a lot easier for people to manage and run containers. And so if any of you have used containers, I'm sure you've at least heard of Docker or are familiar with just how great that technology is. But of course, when it became so easy to run containers and manage them, it turns out that people started using lots and lots of containers. We started to adopt things like these microservices architectures where our monolithic applications got split up into little pieces and then run simultaneously. Now, when you have lots and lots of containers, you need to find a way to orchestrate them. And so Google saw that in the industry there was such a big movement towards containers. And we thought, let's take the experience that we have running containers at scale and let's make it just as easy for everybody else to do it. And so 5.5 years ago, we released Kubernetes. And when I say we released it, we actually open sourced it, the whole code base, the trademark, everything. And today, in just that 5.5 years, Kubernetes is the standard way to run containers at scale. Every cloud vendor supports a Kubernetes hosted platform. But we didn't stop there. In more recent times, we've been working on things like Istio, which gives you the ability to manage your services the way Google does, so that you can deploy things like site reliability engineering practices. We still continue to listen to our customers, though, and what our customers are telling us is that almost 3/4 of organizations already use the cloud in some way. Maybe in a big way, maybe in a tiny way. But actually, not as big as you'd think, because only 10% of workloads have moved. That leaves the 90% of existing workloads on-premise still, or in a local data center. The other thing customers are telling us is that they've made big investments in their data centers. They've got big investments in their on-prem infrastructure, and moving to the cloud, they want to be able to adopt the cloud, but they don't want to just throw away those investments. They want to be able to continue to leverage what they have and move incrementally to the cloud. Additionally, customers are telling us that they don't want to tie themselves to a single cloud vendor. They want to be able to support multi-cloud. So hybrid cloud is where we've got something on-premise and in the cloud. Multi-cloud is when we're supporting multiple cloud vendors. So our customers are telling us this. Now, we saw that only 10% of workloads have actually moved to the cloud, and actually, out of that 10%, some of them actually didn't succeed in moving to the cloud. They ended up rolling back to being on-premise. Now, if you think about why that might be, is because a lot of customers tend to try and modernize their application. They sort of pull apart these monolithic services and try to make microservices out of them. But they try and do that re-engineering work at the same time that they are moving to the cloud. Now that's fraught with risk. You're re-engineering important parts of your application. You're suddenly familiarizing yourself with new processes, new tools. You're not familiar with what's there. Everything feels a bit new. So it's not surprising that some organizations may struggle to do that. Wouldn't it be awesome if you could somehow modernize while you were where you are in place on your on-prem setup in your data center before you move to the cloud, so that when you wanted to move to the cloud, things were already ready. You'd done the modernization work locally. But to do something like that, you need a platform that works in the cloud as well as in the data center. And you want the benefits of an open ecosystem, like Kubernetes. The platform itself also needs to be consistent across those different environments. You don't want to have a separate set of tools to manage your cloud environments versus your on-prem or your data center environments. You want those things to be consistent, because you want to manage that entire estate of infrastructure that you have with a consistent set of tools and policies. You want your people to be able to interact with a single platform. So I want you to come on a journey with me. I want you to imagine a world where you can seamlessly move workloads between public clouds and on-premise infrastructure. We built that, and we call it Anthos. Now, Anthos, as I said, is different things to different people. At a high level, Anthos is an application deployment and management tool for on-premise and multi-cloud setups. But the thing that makes Anthos different is that it is a 100% software solution. There is no hardware lock-in. For you, your infrastructure is abstracted away so that you can focus on building apps, not on managing infrastructure. And because Anthos is built on a set of open technologies, you can avoid vendor lock-in. Now, I'm not going to go through all of the milestones that got us to Anthos, but I want you to realize that Anthos is not something that we just built overnight or in a year or two. It's the culmination of decades worth of work at Google. From us running containers, starting to run containers all the way back in 2003, to making that open source with Kubernetes, and now making it available to you to migrate your workloads. Anthos has different sets of tools for different types of people in your organization. So we have a great developer experience for the developers that are building native applications. I'm going to talk about all of these things, so if some of these are unfamiliar, don't worry. We make it easy for you to run your services like Google with things like Istio, and we enable you to deploy your containers at scale with Kubernetes. Now, these are all open platforms. This is all open source software on the left-hand side. And on the right-hand side, we offer gold-class hosted versions of each of these services. Now, when you work on-premise, we bring these experiences to you with VMware. And we're going to look at how that works. So these are all the components that make up Anthos. Now, if you're like me, when I first saw that diagram, I was overwhelmed. I was like, whew, there's so much happening here. Like, how am I supposed to make sense of all of this? Well, trust me in saying, when I say to you that over the rest of this presentation, I'm going to cover all of these components, and by the end of this talk, I'm quite confident that you will understand exactly how these pieces come together, because we're going to build this diagram from the bottom up. So let's go back to Kubernetes. When we open-sourced Kubernetes and released it to the world, we identified cloud-native applications in 3 ways. The first is that they are container packaged. They're portable, they're predictable, then they have isolated resources. The second is that they are dynamically scheduled. So we use a machine to allocate clusters across other machines. And the third is that they are microservices oriented. So each of these components are somewhat loosely coupled and support independent upgrades. Now, when we released Kubernetes, we also followed up with our hosted version of Kubernetes called Google Kubernetes Engine, GKE. What this meant is that we made it much easier for you to run your Kubernetes clusters on GCP. The open source version of Kubernetes was available and still continues to be, so you can take it and deploy it in your own infrastructure if you like. But Google Kubernetes Engine makes it so much easier to run Kubernetes than the open source version. So for example, if you are an expert in Kubernetes, it could still take you hours to bring up a cluster because of the work that's involved. With GKE, we have a friendly user interface on the Cloud Console. You click a few buttons, and a few minutes later, you have a running cluster. The other thing that we do is more of the day 2 or maintenance type tasks. So, when there's a new version of Kubernetes that's been released, either a major version or something like a security update, we offer those updates to you with a single click where you just have to accept that, yep, I want to upgrade to that version, and we handle that for you. We bring your cluster down, provision the new cluster on a new version of Kubernetes, and you're on your way. That type of work is really, we've had customers tell us that it can take days of their week to do those sorts of upgrades, and we do those for you within seconds or minutes. And we offer great integration with our other cloud services. Now, what's new with Anthos is this on-prem version of GKE. So on your own infrastructure, you can now run GKE, not just the open source version of Kubernetes. And what that means is we bring you those great features from GKE on your on-prem infrastructure. We do your upgrades for you. We maintain things like automatic node repair and so on. And this part sits on top of VMware's vSphere in your environment. So I want to show you the difference between Kubernetes, GKE, and GKE on-prem. So if you've ever used Kubernetes, you'll be familiar with this kubectl command. That's how you administer your clusters. You create clusters and so on. Kubectl actually communicates with the master there, which basically tells it, hey, go and deploy these containers, and this is what kind of scaling I want you to have, and so on. It's pretty simple. So kubectl talks to the master with a set of APIs. When you use GKE, you still can use kubectl, and it will still work with your GKE clusters, but you also have this interface in the Cloud Console where you can administer it that way. Again, using the same APIs. Now, things change when we go to on-prem. So when you go to GKE on-prem, we have an admin workstation, and you use the GKE ctl command to talk to this new type of cluster called an admin cluster. Now, this admin cluster is responsible for creating your clusters for you in your environment. So kubectl is still used to administer your own user clusters, and GKE ctl is there to help set up your environment. And you're not limited to a single cluster either. You can have as many clusters as you like, only limited by what your infrastructure supports, your on-prem infrastructure. So with things like kubectl, we give you that consistent experience regardless of whether you're on open source, GKE, or GKE on-prem. But of course, wouldn't it be easy if we could just use our Google Cloud Console? We make that easy for you too. So when you have GKE on-prem set up on your on-prem infrastructure or in your data centers, the Cloud Console shows you a single view of all of your clusters and all of your estate. We don't discriminate between, you need to go to this view for your particular data center here in Delhi, or a different view for Mumbai, and so on. We can show you that entire view between GCP and on-prem collapsed as if it was just one. We have a column that basically allows you to see whether it's actually in GCP or whether it's on-prem. So we make that easy for you. And the way that we do that, by the way, is that when your GKE on-prem starts up, we make a single outbound connection that's TLS secured to GCP. Now that connection is what registers your GKE clusters so that they are visible up on the Cloud Console. Now the cool thing about this being an outbound connection means that you don't need to expose your on-prem infrastructure with an external or a static IP address. It can be NATed all the way through, but it's just that it's an outbound connection, so it's able to do things like on the Cloud Console, you can provision more clusters, you can push out Kubernetes upgrades, and so on. So that's it. This is the start of our diagram. We have GCP, we have the GKE dashboard, which is the Cloud Console that I keep talking about. We have GKE, Kubernetes engine on GCP. On the on-prem side, we have GKE on-prem. But effectively, we give you the same experience, whether you're sitting in GCP or whether you have things running on your data center. And we have interconnect, cloud interconnect there that allows them to communicate with each other. So this is the start of our diagram. It's nice and simple. Let's add to it. I've mentioned a service mesh a couple of times. The way we define a service mesh is that a service mesh provides a transparent and language-independent way to flexibly and easily automate application network functions. That's a mouthful. So why don't we talk about what that actually translates to in real terms. So a service mesh is a network that's designed for services, not for bits of data. It's a layer 3 network that doesn't know what application or service it actually belongs to. It doesn't make routing decisions based on your application settings, and it doesn't know that these packets are called those packets in your network. So by automatically deploying a mesh of smart proxy servers alongside your application, you can get uniform observability into your workloads at a service level, which allows you to make some smart decisions about routing traffic, about enforcing security and encryption policies. So you get things like observability. You can look at all the state of your application throughout. You can get things like the ability to split and route traffic based on your application. And I'm going to show you an example of this, which will, I hope, make things a lot clearer. And then you can apply some policies as well to make sure that your application is working exactly the way you expect. So let's have a look at a simple application. We have a front-end component that all our end users connect to. That once they connect to front-end will authenticate those users using a Google Cloud SQL table. Front-end will also be able to fetch some pictures. So this particular service that we're running, it's a photo service where people can purchase photos. And then we have a payments processor, so your users can go ahead and purchase those actual components, those photos. Now, the first thing you notice here is that these lines that connect each of these components, front end is the only component that talks to all of these, right? So right now, I mean, it's a nice clean diagram in that sense. Typically, though, we don't have a nice way to enforce security policies to say, hey, there's no way that pictures should ever talk to auth. Well, Istio can enable things like that. The way we turn on Istio, enable Istio on a service, we're working in the Kubernetes world here, so we've deployed this front-end image. It's part of our pod. Instead of that, what we do is we add a second image there, which is the Istio proxy, which makes it Istio-enabled. What that does is that it injects a network proxy close to the workload, sitting right alongside it within that pod. And that smart proxy captures all inbound and outbound network connectivity. So everything will automatically go through that. The fact of the matter that this thing is injected in and it's a transparent proxy is really important. Because how much change did we make to our code to make this happen? Nothing. We got Kubernetes to do it for us, right? We deployed the proxy. So now we're able to capture all inbound and outbound traffic, and we can make some smart decisions about how we route that traffic. So eventually, we end up with something like this, where we put proxies next to each of our components. And now that we're capturing that traffic, we can do things like encrypt that traffic. We can do things like enforce policies so that the pictures component can't talk to any other component other than front end. And we did all of this without making changes to our application code. We have a nice, clear separation of our coding from our development team, from our developers, and then on the operations side. So we can deploy it in the way that we want to without, again, having to make these code changes. So Istio is really awesome like that. Let's talk a little bit about how Istio works. Istio has a control plane to make this all happen. And that control plane has 3 conceptual components. The first one is the pilot. You see it on the bottom left there. The pilot talks to all of the proxies and deploys configuration and routing rules. The mixer comes along and enforces the policies. The mixer says, hey, who's allowed to talk to which other component? Is front end allowed to talk to pictures? Okay. Is pictures allowed to talk to auth? No. Mixer is the one that's going ahead and enforcing those things. Mixer does actually some other really cool things. It captures telemetry. And because it's got a flexible plug-in model, it can take that telemetry and send it to a destination. So what's an example of telemetry? Logs. If you've ever had to diagnose problems in a Kubernetes environment, you know how frustrating it can be to collect and centralize all the logging. That's a simple feature of any application. Well, with Istio, we can get the logs from all of our workloads and send them to a single destination. Finally, we have the Citadel, which deals with security inside the cluster. Think of the Citadel as acting like a certificate authority for your cluster. And it issues certificates to all the proxies in the mesh. Now that's really, really interesting as well, because what that means is if one of your components gets compromised, the rest of your system can't get compromised. And because we are acting as a certificate authority, someone else, something nefarious on your network can't just hop in and connect to any of these things because they're not being secured through our Istio network. Again, we're not doing this with any changes to the application. So Istio is really, really forward-looking in that sense. So far we've talked about this traffic control piece. We've seen that communication is transparent, is secured transparently using MTLS. So besides controlling the routing of traffic, what else can we do? On the testing side, you can also do things like inject errors into your network to see how resilient your network is to those. You can put things like rate limiting to see how often the front-end service is calling the auth service, for example. And last but not least, a mesh is able to extend a cluster. So you can route service calls and enable service discovery across underlying platforms. So it doesn't matter if those platforms are Kubernetes, virtual machines, on-prem, or any multi-cloud provider. So Istio is really changing how we're deploying applications in big ways. So continue, what I'll tell you is that whilst it's already doing some cool things, you're going to continue to see some really great improvements in months and years to come. Now, just like with Kubernetes, how Kubernetes is open source and we have a managed version of Kubernetes or a hosted version of Kubernetes, we have Istio on GKE, which is our hosted version of GKE. Now, Istio and Kubernetes are independently released, right? So they have independent versions. So by using Istio on GKE, what you're doing is you're putting your trust, you're letting Google go and do the certification for version compatibility. So when there's a new version of Kubernetes, we'll have matching versions of Istio that are tested and certified and paired up. So Istio on GKE gives you that. When you upgrade your Kubernetes environment, and again, we make that so easy for you, we'll do the same thing for Istio as well. Now, with Istio on GKE, we also add some additional adapters to plug into other GCP products. So first one is the Apogee adapter, but the one I want to call out is Stackdriver. So remember a couple of slides back, I said the mixer component captures all the telemetry and sends it to a destination. On GCP, that destination by default is Stackdriver. Stackdriver is awesome. I'm going to talk about it a little bit in an upcoming slide, and then Yoshi is going to talk about it in the next talk as well. But in this context, the Stackdriver is going to grab all your logs and traces and make it really easy for you to see what's happening inside your system, to give you observability. So now when we look at our diagram, we have Istio on GKE on the GCP side of things, and we have the open source version of Istio running on your on-prem data center. So our diagram is starting to fill up a little bit. Now, what I've been able to show you so far is that it's pretty easy to create clusters, right? So what happens in IT when you make things too easy? People deviate from the plan, right? So you have this beautiful plan that everything's going to be nice and consistent like on the left-hand side, But ultimately, because things are easy, people just do what they need to get the job done. And you get a scenario a bit more to the right-hand side like that, where each of those things independently look fine, but together it's not consistent. Now, Kubernetes solves this by having this pattern where you specify your desired state with your specs, and then a controller continually monitors the environment to make sure that your actual system is meeting that desired state. So we introduced a new component called Anthos config management to make it easy for you to apply your policies between this heterogeneous environment of multi-cloud and on-prem. So what Anthos config management does is it lets you enforce guardrails for centralized IT governance. So you can manage configurations of the tools in all of your clusters in one single place. You don't need a separate repository for on-prem and a separate repository for either any of your cloud providers. It's a single auditable source of truth. And again, if you've used Kubernetes, you've probably heard of the term infrastructure as code. Well, with Anthos config management, you now have policy as code, where we use this Git repository where your policy gets checked into. And then you get all the benefits of Git, right? You've got traceability, you've got things like pre-commit validation, you can label things so that you've got well-known working configuration. So if something goes wrong, you can always roll back. Now when we look at our diagram, we've added config management on the left-hand side here on GCP. And in the on-prem setup, we have a copy of the policy repository stored locally that config management is constantly applying. And that policy repository is always being synced between your GCP environment and your on-prem setup. Now, so far, we've talked about Kubernetes, about deploying containers at scale. We've talked about Istio, about making sure that we can secure those services, capture our telemetry. We've talked about config management to make sure that we can synchronize our application and tool settings between on-prem and the cloud. One important area we haven't talked about is actually our applications. How do we run applications in this modern world? Well, there's multiple ways that you can run your applications. Many customers choose to use VMs today, right? Some customers tend to use containers and so on. One of the things that cloud is changing is how people think about designing their applications. So you may have heard the term serverless in the past. Serverless is this reasonably recent term that what it does is it refers to applications that don't have to be concerned with the infrastructure. The infrastructure is abstracted away from you. So when you're thinking of your applications, you just think of app development, not about the deployment scenarios. Serverless also changes the billing model so that you pay for what you use rather than pre-allocate a VM that's so big and have a fixed cost. So depending on the busyness of your application, the cost of your application will go up and down. Now, with Kubernetes, people have been asking, how do we bring serverless applications to Kubernetes? So we took a look at this, and we built an open source framework called Knative, which enables exactly this. And Knative, just like Istio, just like Kubernetes, we didn't build it in isolation. We originally open sourced it, and now we're working with vendors across the industry to make sure that this is the best serverless infrastructure, serverless framework that you can get for Kubernetes. So once you have Knative, though, that's the open source implementation. Google has taken Knative and provided a managed version of the product called Cloud Run. And in this talk today, I cover lots of things. And I can tell you unashamedly, Cloud Run is the thing that has me the most excited. Cloud Run is amazing for application developers because if you've got any stateless components in your application, you can package them up in a container and just give it to Cloud Run. Cloud Run is going to deploy it for you, going to give you a secure URL that you can map to your own domain, and it will scale it for you. You don't need to think about any of the rest. You just focus on your code. And the contract with the Cloud Run container is simple. One is that it's stateless. So for all your stateless components, Cloud Run is perfect. And the second is that we give you the port that you should run on as an environment variable. So when you start up, you look at that environment variable, and you start your application on that. That's it. Now, when we think about, remember at the start of this, I said, oh, people are trying to modernize their applications, and whilst they're moving to the cloud and things like that, Cloud Run makes that journey so much better. Because at the end of the day, this is just a container, which means you can write in whichever language you want. You can use any tools you want. You can have any dependencies you want, put them into that container, and we handle the rest. So in terms of bringing across legacy applications that are not working on the latest versions of Java or Python and so on, we support all of this. You could be a COBOL programmer. You might write Haskell or Pascal, right? All of that is just supported because at the end of the day, on Cloud Run, it's just a binary. So the reason I'm excited about this is that Cloud Run allows me to bring and deploy my applications to this modern cloud-native world, but it allows me to continue to operate in an environment that I'm comfortable in, that I already have an existing skill set. So Cloud Run is really great, and I really encourage you to check it out. Now, I did tell you that with Cloud Run, you give it the container image, and it will deploy it and scale it for you. Sometimes you want a little bit more control than that. You don't want it to be fully automated. So let me give you an example. Let's say you're doing some machine learning, right? You have big data sets that you need to train your application on. Now, typically with machine learning, CPUs aren't enough to train our data against our data set in a quick enough manner. So sometimes we use GPUs. Google also offers TPUs. Now, if you want to deploy your containers against specific hardware like that, typically you do it with Google Kubernetes Engine, and you can target your clusters based on the hardware that they provide. So we have a version of Cloud Run called Cloud Run for Anthos that allows you to deploy your Cloud Run applications on your clusters. So that gives you freedom to run Cloud Run anywhere. You can run the fully managed version of Cloud Run where you just give it a container image and we'll deploy it for you. Or you can use Cloud Run for Anthos where you can deploy it on your Kubernetes clusters. And when we've been talking about Anthos this whole talk so far, what we've been saying is Anthos is allowing you to bridge an on-prem world with the cloud world. So if you want to deploy your Cloud Run applications on your on-prem environment, Cloud Run enables that. You can continue to leverage your existing infrastructure. You can move it to the cloud whenever you want, and you may choose not to. You may be happy with that specific application. If at some point you feel like, oh, I want to be vendor neutral, what peace of mind you have is that Cloud Run is a managed version of Knative. So that application, you're not locked into Google's proprietary platform because Knative is open. That contract that I told you about Cloud Run, it's just Knative. So you can take that and deploy it anywhere that Knative runs. And I can tell you now, Knative runs everywhere across every major cloud provider. So it's great. When we build our applications, we want to be able to test them. We want to be able to have insight into them. So the second thing that I'm super pumped about talking to you about is Stackdriver. Stackdriver is our tool for observability. And we referred to Stackdriver earlier when I talked about Istio. Istio, when you enable Istio and GKE, it takes all the logs and telemetries from your Kubernetes clusters and sends them to Stackdriver. So you have this one tool where you can see the logs across your whole estate. It's super powerful and super useful. Stackdriver has also things like application debugging built in. So you can link Stackdriver to your source code and set up breakpoints. And when that breakpoint is hit, your production system will continue. Your users don't notice. But Stackdriver will take a snapshot of the state of your application and send it to you. It'll store it for you in a queue, and you can debug it at a later stage. So it allows you to get in and identify those problems that you might be having in production that you can't reproduce anywhere else. But it doesn't bring your production system to a halt in order to do it. Stackdriver is awesome. So again, this is a tool that's very worth your while checking out. And finally, we have the marketplace. Because ultimately, there are times when we don't need to build everything ourselves. You may just say, hey, you know what? I have a specific job to do, and Redis does a fantastic job of that So I just want to deploy Redis on my Kubernetes clusters. So we have this GCP marketplace where we've worked with a whole bunch of third-party vendors to certify software running on GCP. And you can deploy those applications on your Kubernetes clusters. And thanks to Anthos, those clusters could be on-prem or they could be in the cloud. The other nice thing that the marketplace does is that it gives you all of the billing for those third-party tools that you use on your Google Cloud bill. You don't need to write up a new contract or purchase order with another customer or another vendor. It's all just simplified on your GCP bill. There'll be a section there for whichever marketplace apps you use. And there you have it. We've gotten to the end of our diagram. We've added marketplace in the middle and Stackdriver in the middle. So now we can explain all of this. We have Kubernetes engine and GKE on-prem for orchestrating our containers. We have Istio to help us make sure that we can put security policies. We can do traffic routing across the services in our estate. We've got Anthos config management and the local policy, and as well as Anthos config management on-prem to make sure that we can have a centralized place for all of our governance, application settings, and policies, so that they're consistent between our environments. We don't have a separation between those things. And then we have the marketplace and Stackdriver to help us have a much better application experience as well. So up until now, everything I've talked about has been predicated on one thing, and that's containers. A lot of customers out there today deploy their applications with virtual machines. And for those people that have been looking to migrate to containers, it's been not always an easy journey. So to make that easier, we've got a product called Migrate for Anthos, which literally takes your VMs and converts them into containers. What that does is that your container images are much smaller because you don't have a whole copy of an operating system. We also reduce the burden on you so that when you deploy a container, you've only got your application to package in that container. You don't have to apply security updates and so on to the operating system, right? Because we do that on our hosted infrastructure. Ultimately, rewriting applications to fit into this cloud-native world, it's not realistic. There's lots of legacy applications out there. Things like Cloud Run, things like Migrate for Anthos, make it easy for you to take your existing applications and bring them onto GCP, whether it's on the cloud or on your on-prem setup, thanks to Anthos. So if you want to get started today, check out GKE, cloud.google.com/GKE. Check out Cloud Run. Really take the chance to look at Cloud Run if you're a developer, because I really think it's a game changer in terms of bringing legacy applications across and just also having a great developer experience. And finally, have a look at Istio, because it's really reshaping the way we deploy applications. So that's Anthos. We're very proud of it, and we're delighted to see what you're going to make of it. So thank you very much for having me. All right.